All right, let's jump right into it. Welcome to today's explainer. We are diving headfirst into a really comprehensive grade 10 science masterclass today. We're drawing directly from Buena Vida's P. Gerendio Jr.'s presentation to totally unveil the unseen chemical changes that are literally happening right in front of our eyes every single day. Here's our quick roadmap for this explainer. First, we'll cover physical versus chemical properties. Then we'll explore the big 3 clues of reaction. After that, we'll apply this to real-world chemical safety, and we'll wrap the whole thing up with a comprehensive knowledge check. Okay, moving to section 1, properties, physical versus chemical. Now, before we can analyze how matter reacts, we kind of have to know how to observe it, right? And there is a super stark contrast between these two. Chemical properties can literally only be observed when a substance undergoes a fundamental change in its composition. Physical properties, on the other hand, those are characteristics you can measure without changing the substance's identity at all. The identity stays entirely 100% intact. So, looking a bit closer at physical properties, we're talking about everyday things: color, hardness, malleability, solubility, electrical conductivity, density, and melting or boiling points. The absolutely crucial takeaway here is that when you observe the color of a rock, or say you melt a piece of ice, you aren't fundamentally altering what that substance actually is. Water is still water, even when it's ice. But how does this change with chemical properties? Well, think about things like toxicity, reactivity, flammability, heat of combustion, oxidation states, acidity, radioactivity, or bond types. It's a whole different ballgame. You can't test a substance for flammability without, actually trying to burn it. Testing these inherently changes the fundamental composition of the substance you're examining. All right, section 2, the big 3 clues. Put on your detective hats for a second, because we are looking for the real-time, undeniable signs that a chemical reaction is taking place. In our source material, we have 2 classic observation activities that hit the nail on the head. First is the mystery tablet activity, where a tablet is dropped in water, you watch it, you hear it fizz, you feel the class. Second is mixing yeast with hydrogen peroxide, where you're tasked to smell for new odors and feel for temperature changes. Just imagine that bubbling fizz and the sudden warmth in your hands. And those activities brilliantly illustrate our big 3 clues. Clue number 1 is gas release, which you'll usually see as bubbles or fizzing. Clue number 2 is odor change, meaning entirely new smells. And clue number 3 is temperature change. Now remember these specific scientific terms. Exothermic means it heats up, and endothermic means it cools down. These 3 clues are your primary, flashing neon signs that a completely new substance is being formed right before your eyes. Moving on to section 3, real-world chemical safety. Recognizing these changes isn't just for acing a science lab. It is absolutely vital for everyday safety in your own home. How do the big 3 clues apply to your kitchen or your garage? Well, bulging containers, that suggests a dangerous gas buildup inside. Strange odors could mean invisible chemical leaks or food spoilage. And unexpected heat radiating from something, that is a major red flag of a potentially dangerous reaction. Spotting these clues early can literally prevent accidents. So if we focus our lens on the absolute core lesson today, it's this: chemical reactions create new substances. Physical changes, like melting or cutting, just don't. Spot the gas, the color changes, the temperature shifts, or the new odors, and you stay safe. It's that simple. Okay, section 4, formative assessment knowledge check. Let's lock in everything we've learned with a rapid-fire reviewer, testing our basic understanding all the way up to our critical evaluation skills. Let's see what you retained. Question 1, just testing our basic understanding. Which of the following is a sign of a chemical reaction? Is it melting ice, gas release, cutting paper, or dissolving sugar? Well, if you remembered the big 3, you correctly chose gas release. Question 2, let's apply this. What evidence is observed when vinegar and baking soda are mixed? Is it freezing, evolution of gas, turning into gold, or no change? Think back to that classic childhood volcano experiment. Yep, it's the evolution of gas. All right, question 3 is a quick understanding vocab check. An increase in temperature suggests a reaction is endothermic, exothermic, physical, or reversible. Remember, heat is exiting, which makes it exothermic. Question 4, moving right along. What does a new, pungent odor usually indicate? Evaporation, a physical change, a chemical reaction, or cooling. A brand new smell almost always means a chemical reaction has taken place. Question 5. Applying what we know about temperature again. If a reaction feels cold to the touch, is it exothermic, endothermic, combustion, or boiling? This is the exact opposite of question 3. Cooling down means it's actively absorbing heat, so endothermic. Okay, question 6 requires a little bit of analysis, which is not evidence of a chemical reaction. Color change, light, shape change, or a precipitate. Changing the shape, like simply crumpling a piece of paper, keeps the core identity intact. So, it's shape change. Question 7. When a candle burns, what gas is released? Oxygen, carbon dioxide, nitrogen, or helium? The process of combustion releases carbon dioxide into the air. Question 8 asks us to evaluate a scenario. Rusting iron is a chemical change because of a shape change, a color and composition change, melting, or dissolving. Rust is an entirely new material, right? So it's a color and fundamental composition change. Question 9, back to analysis. Bubbling without heating suggests boiling, freezing, gas release, or condensation. Think back to the mystery tablet sitting in room temperature water. Unheated bubbling is a dead giveaway for gas release. And finally, question 10. Why is odor change evidence of reaction? Is it because new substances are formed, the original substance is gone, it's boiling, or it's cold? This totally reinforces the ultimate rule of our explainer today. New smells mean completely new substances have formed. Awesome job on that masterclass assessment, seriously. So we've broken down physical versus chemical properties, we've explored the big 3 clues, and we've connected them to real-world everyday safety. I want to leave you with this final thought. Knowing what you know now about gas, temperature, and odor, are you observing the chemical changes happening around you every single day? I highly recommend putting on that scientific lens and really starting to look. Thanks for joining me on this explainer, and keep learning.